let's start with the theory part of dynamic programming in this lecture. And let's see if we could cover one of the problems, because I've taken a very easy small numerical, so that we can, if possible, can invest our time in solving the numerical or understanding the numerical of dynamic programming, right? So, what is dynamic programming now? Here, no, here we have a word, dynamic programming. So here, what will happen? The variables are dynamic in the nature. Dynamic in the sense, the variable can take different values, according to the different time interval, right? So that is the particularly case with this dynamic programming, right? So it is here the mathematicians who have developed this dynamic programming, it was developed way back in 1952 by Richard Gellman and Danzig, like. But they have specifically stated, though that this technique is called as a dynamic programming, but it can be used in the various aspects where the variables change according to the time or the different stage. If you see how it is related with civil engineering point of view, in I would you would have definitely heard of the topic called as milestone, right? So milestone basis project, right? So in what happens in milestone basis project is that we divide that particular project. Let's say if I'm particularly having or I'm having a building to get constructed, and it is having 15 floors, right? And each floor I am considering as a milestone, right? So what happens is that I'm checking the progress of my project with after every milestone. So after finishing every floor, I'll be my each milestone is getting particularly completed, and I'm checking that progress or against that particular milestone. So in civil engineering, what is this milestone? This milestone is going to change with respect to time. Let's say for first 15 to 20 days, it will be our first floor, and then after again 20 to 25 days, it will be our second floor. So what is happening? The milestone is going to get changed every after every some time interval, and we are going. Let's say that our progress or our cost is a variable, and we are going to check the cost that we have invested again after every milestone or every stage. So particularly what is that particular cost or that the investment that we have done is a variable, and that is going to change every particularly for every milestone. So against that particular investment we have done, we are going to check if that was our targeted investment or not, right? So the actual investment is equal to the targeted investment, or we have particularly invested more or invested less, and what is the reason if why we have invested more. So if we will be identifying what are the reasons, and we'll be trying to overcome that particular reason, so that in the future, in the future for the future floor, for the future milestone, you don't have to invest much cost, or you don't have to do lot of any investment. Again, if the investment is less or against the targeted investment, so what we are going to do is we are going to check why that investment has been less. It has been because of some of the measures that we have taken or not, and what measures we have taken so that the investment became less. Is that less investment hampering our safety of that particular structure? So what is this? This is after every milestone we are going to check, and for every milestone the variables are the same. That is the investment cost. The variable is remaining same, but it is attaining a different value after every stage. So this particular dynamic programming is also called as multi-stage decision problem, right? Multi-stage decision problem, and that means that every stage we are going to take particularly some decision. That decision is going to affect our next decision, and particularly what will happen, we are going to achieve the totality. We are going to achieve the optimality in the entire in the totality, not at an individual stage. ऐसा नहीं होगा कि इंडिविजुअल स्टेज पे हम लोगों ने कुछ किया और वो ऑप्टिमल पर्टिकुलरली आपका सॉल्यूशन देगा नहीं. आपका ऑप्टिमल सॉल्यूशन क्या होगा एट द एंड ऑफ योर कंप्लीट प्रोजेक्ट. No, particularly you have invested less time, you have invested less cost. So that is you are achieving the optimal variable, attaining the optimality. But every with the help of every stage, what we are going to do is we are going to take small steps. We are going to take small steps. Because of those small steps, what is going to happen? The no, the overall objective is going to get satisfied, right? So we are going to take decisions at every stages, right? And we are going to achieve the optimality at a at a larger level or at a complete level, right? So I'm hoping that this basic idea you have got out. And let's particularly read out some interesting the distribution characteristics and all those things for the dynamic programming, and then we'll be seeing the numerical for a dynamic programming, right? So let's start. So this is no mathematical technique already said, and it is it is used for or it is dealing with the multi-stage decision problem. This is very important. Why there is a need of this particular dynamic programming, because there are some problems in the real life or particularly in the that we have to handle, whose variables are going to change after every stages, right? That stage can be a time factor, right? So it is originated in 1952 by Richard Wellman and G.B. Danzig. So in real life, we may come across the number of situations where the decisional variables vary with the time, and these situations are considered dynamic in nature. The technique dealing with such problems is called as your dynamic program, right? So your milestone basis project are the best examples of this particular this thing. Now every project, particularly it is made, every civil engineering project is made as a milestone project only, right? So if you even if you are hearing of the metro construction that is going on, so if you read a news into this, read the news. So what they normally say that the next milestone got completed, the tunneling part or the underground works from this particular point to this particular point got completed. So this is the new milestone that they have achieved, right? So माइलस्टोन बेसिस पे ही अभी क्या होता है, काम चलता है. एंड माइलस्टोन बेसिस पे हम लोग क्या करते हैं, पर्टिकुलरली हम लोग चेक करते हैं कि हम लोगों ने जितना हम लोगों का प्रोग्रेस है वो राइट डायरेक्शन में जा रहा है कि नहीं जा रहा है, जो हम लोगों ने कॉस्ट वहाँ पे इनकर कर रहे हैं वो ठीक है कि नहीं, हम लोगों का जो टाइम, कॉस्ट और बाकी जो भी फैक्टर्स है वो सब चेक करने के बाद हम लोग एक डिसीजन पे आते हैं कि दिस इज गुड और दिस इज बैड, the progress is happening in good manner or happening in the bad manner. Then the analysis is done, why it is good, then why it is bad, and accordingly the decisions are particularly taken for the next milestone or next stage, right? So that particularly is called as the multi-stage decision making or the milestone basis project, right? So there are some distinguishing characteristics of the dynamic programming that you should know, right? So what happens in the dynamic programming is that it splits the original problem into smaller sub-problems which are called as the stages, involving only a few variables, wherein the outcome of a decision at one stage affects the decision at the remaining stages, right? So this is very important. What happens is that the bigger problems get divided into smaller sub-problems which are called as the stages, right? And it involves, every stage will involve only a few number of variables, wherein the outcome of the decision at one stage will affect the decision at the remaining stage, right? So this is very important. So every stage is important. We can't say that the initial stage is of no importance and the only the last stage is important or only the mid stages are important. No. Why every stage is important? Because the decision or the outcome at every stage is going to affect the remaining stages, right? So that is important. Now it involves the multi-stage decision making, right? The point at which the decisions are made are called as the stages, right? So we are not going to make the decision at each and every day. there are some stages that are marked, and there are some points that are marked, and at that particular stage only we are going to take a at that particular time we are going to take the decision. So those are called as the stages, right? The stages may be certain time interval or certain subdivisions of the problem for which the independent feasible decisions are possible. Why it is not taken at the regular basis? Because we cannot take independent feasible decisions every now and then, right? So a particular time interval or a particular subdivision has been identified. At that particular subdivision, we are able to take independent feasible decisions, right? And that particular point is called as nothing but a stage, right? So each stage can be thought of having a start and an end, right? So every stage, a project for a project in a totality will have a start and end. But here, what we can do, every stage we can think of, this is the start point and this is the end point for a particular stage. And the stages will have a sequence, right? The sequence is very important. Then only the optimality in the total is going to get achieved. You can't alter the sequence, right? Particularly, right? So the stages are going to be in the sequence only. End of the stage will mark the beginning of the next stage, right? So this is very, very important. Why there are stages, right? So because at this particular stages we are able to take the independent feasible decision. Each stage will have a start and end point, and the stages will have a proper sequence. At the end of this stage will be the beginning for your next stage, right? So the variables which are linking these two stages are called as the state variables, right? So this is the state variables. What are state variables? Variable linking two stages are called as the state variables. At any stage, the status of the problem can be defined as by the value of your state variable only, right? So there is a linking between your previous stage and the next stage. That variables are called as the state variables. And if I have to check the status of that entire problem or the entire project, I won't be particularly dealing with the other things. I'll be just just checking what is the particularly what is the status of your state variable, and with the help of that entirely the entire progress can be, or the entire status of the progress can be judged, right? So I remember when I was in LNT, we would have the planning meetings, right? So we were to give, I was working for a few of these projects as a planning engineer, and when I was to give the presentation at the regional office, they will be asking me only asking me only one value. That was an indicator value, and they will be with particularly only that value they will be able to, the regional manager will be able to get the entire information of that particular project, right? So there are some indicator values that are been assigned. So these are nothing but those indicator values are again what those are nothing but your state variables only. And the work that you do particularly that with the help of that the again with the completion of every stage, the indicator values or the state variables will are going to achieve some different values. So few indicator values, and the regional manager or the top management is it knows what is the status of that entire project, right? So these are such kinds of the particularly state variables are there. And the state variables are very, very important because the outcome of the decisions depends upon the particularly your state variables only. So here also there are small number of variables. So again your state variables are again a small number of variables only on which the decision will be depending. A stage decision does not alter the number of variables and which the at which the outcome depends, but only changes the numerical value of this variable. So this is very, very important, right? A stage decision does not alter the number of variables, right? So at every stages, the number of variables or the variables are going to remain same, right? Only the values of these variables is going to get affected, right? So there is only the change in the values of the numerical values of these variables. Otherwise, the number of the variables or the type of the variables that you have decided at the initial stage is going to remain same till the last the end of your complete project is achieved. What is only going to happen is that these variables are going to take the different values in every stage, right? Now there is a very important principle of optimality that has been derived by Bellman, and the dynamic programming is based upon this entire optimality principle, right? So what is that principle? An optimal policy, that is a sequence of decisions, has the property that whatever the initial state and the decisions are, the remaining decisions must constitute an optimal policy with regard to the state resulting from the first decision, right? So this is the principle that he has derived. So in the simple meaning, what we can say, the principle implies that a wrong decision taken at one stage does not prevent from taking of the optimum decisions at the remaining stages, right? So this is a very, very important principle of the optimality that the dynamic programming is following. What is that principle, right? So the principle is there, but what is the literal meaning? So suppose that we have taken the wrong decision at a particular stage. So that particular wrong decision is not going to affect us from achieving the optimality or taking the optimum decisions at the remaining stage. For example, I made a mistake, or particularly what was going to happen is that, let's take a same example. We had a 15 storied building, and at the first story, what we have done, there was some there were some wrong decisions that we made, and because of that wrong decision, there was because of that wrong decision, there were some delays in achieving our first milestone or first stage. But that particular, no, even we have taken the wrong decisions at our initial stages, but that will not prevent us from taking the optimum decisions at the remaining stages. That means that, say, in from second story or till now 15 storied, now though I've taken a wrong decision at our first story, but my optimum decision, I have to take the optimum decisions for my from second story onwards, and that is not going to this wrong decision that I've taken is not going to prevent me from taking the optimum decisions for my all remaining stages. So I can particularly what we can say, uh, apply the corrective actions for the later stages, so that the optimality for achieving the entire optimality that we have to achieve for the entire project will not get affected. तो पहले स्टेज का ठीक है कि मैंने रॉन्ग डिसीजन ले लिया, तो उसके वजह से कुछ मेरा नुकसान होने वाला है, पर वो जो नुकसान होने वाला है वो मुझे क्या करेगा, इट इज नॉट गोइंग टू affect my future decisions. In fact, it is going to help for my future decision, right? So that the wrong decision is particularly not going to affect me, or it is not going to prevent me for taking any optimum decisions for the remaining stages, so that the optimality of the entire project is not going to get hampered, right? So with this principle in mind, recursive equations are particularly made at every stage, right? So here you can see with this particular principle, the recursive equations are developed to take the optimal decisions at each stage. A recursive equation expresses the subsequent state conditions and is based on the fact that a policy is optimal if the decision made at each stage results in overall optimality over all the stages and not only the current stage, right? So what this particularly means is that a recursive equation is going to be made for every stage, right? And that particular recursive equation expresses the subsequent state condition. So that recursive state conditions take into the consideration the previous stages as well. So because of that, what is going to happen is that the total optimality is going to the total targeted optimality of the project that we need to satisfy is going to that is going to get achieved, and it is not going to get affected. So that the recursive function is the it is telling us the, or it is expressing the subsequent state conditions as well, so that recursive condition अगर हम लोग recursive equation भी अगर हम लोग हर एक stage के लिए form करते हैं, तो वो करंट स्टेज का नहीं होता है, इट इज नॉट ओनली फॉर द करंट स्टेज, बट इट टेक्स इनटू द कंसिडरेशन अभी तक के जो हम लोगों ने स्टेजेस को जो हम लोगों ने क्या किया है, सॉल्व किया है, या अभी तक के जो हम लोग स्टेज चढ़ के ऊपर आए हैं, वो सब स्टेजेस को वो क्या करेगा, रिकर्सिव फंक्शन आपका वो सब स्टेजेस आपका ध्यान में लेगा। तो रिकर्सिव जो हम लोग बोल रहे हैं कि रिकर्सिव इक्वेशन आपका हर एक स्टेज के बाद बनना चाहिए और हर एक स्टेज के लिए नया होना चाहिए, पर हर एक स्टेज के लिए नया होने के बावजूद वो क्या करता है, पहले जो स्टेजेस हम लोगों ने जो कवर किए हैं वो स्टेजेस को भी वो ध्यान में लेता है, राइट। So it is not only for the current stage, right? It's cover the overall optimality. The recursive function at every stage will cover the overall optimality, and it is not only going to represent the current stage, right? So dynamic programming provides a systematic approach or procedure wherein starting with the last stage and the problem and last stage and the problem and working backwards, one makes the optimal decision for each stage of the problem. So I'll be explaining this particular point when we solve the numerical. Yeah. Next very important thing is the dynamic programming approach, right? So yeah, I've just written few of the um, important points that we have seen. So we have seen a stage, right? So what is a stage? The problem can be broken down into subsequent sub problems, and each sub problem is referred to as a stage, right? So what is a stage decision now, right? Stage signifies a portion of a decision problem for which separate decision can be made. At each stage, there are number of alternatives, and we have to make sure that we are selecting a feasible alternative. And selection of the feasible alternative is nothing but the stage decision, right? So stage decision is what among the different alternatives that we are going to select a feasible alternative, and that is nothing but we have taken some decision at that particular stage, and hence it is called as the stage decision. The stage decision may not be optimal for a considered stage, but it contributes to make an overall optimal decision for the entire problem. Very important, right? So for a particular stage, when we take a stage decision, the stage decision is always been taken with respect to what? With respect to the overall optimality achievement. It is not for, for only that particular part or for only that particular stage, but it is it is taken for the entire problem. So overall optimal decision for the entire problem has been taken. So that is very very important, right? So state. What is a state? State represents the status of the problem at a particular stage, right? That is nothing but a status, right? And what are the state variables? State variables, the variables which specify the condition of a decision process and summarize the current status of the system are called as the state variables, right? So you should understand what is the state and state variables. I've written the generalized procedure for solving the dynamic programming, but I won't be reciting here as of now. What I'll be doing is that I'll be taking one numerical, and then after solving the numerical, no, I'll be then you can read out you can read out this, and then you can try to correlate. But again, this is a very generalized procedure for solving the dynamic programming. The procedure changes when the type of the numerical is going to change, right? But so there's a numerical. Ms. Vaishali, the project manager of the ABC construction company, is planning a business tour from Ahmednagar to Kolkata. She intends to cover one city from each of the company's different zones on the route, right? So the network clearly shows the three intermediate stages and three possible choices of a route. The travel time between the two cities is inclusive of the working time and is given below the arrow. Which intermediate cities should she visit to minimize the time required to get from A to this A? Right. So A stands for Ahmednagar, K stands for Kolkata, and what she is willing to do is she is the project manager and she is to visit. She is to travel from Ahmednagar to Kolkata, but during her travel, she is interested in visiting only one city from each of the intermediate states. So here you can clearly see that this is one of the intermediate stage, this is another intermediate stage, and this is another intermediate stage. So A, amongst B, C, D, she will be visiting only one of the city. From EFG, she is only going to visit one of the city. From HIJ, she is only going to visit one of the city. Right. So the problem is very simple. You can solve it without a dynamic programming approach or without without recursive function approach as well. But the this but the all this dynamic programming approach or the recursive function approach is being developed for more complex problems, right? So this is a simple problem where you can even with the help of a small aptitude or a small IQ or use of your brain, you can go from A to K with the least minimum value. So, but that is not expected when there is some complex problem that will be happening or that will be coming. So that that strategy won't be working. So we are going to see a universal strategy to help us out from this particular system, right? So no, the solution can be obtained by starting from the first city and going to the destination. No, we are going to start from Ahmednagar, then we are going to move to the particularly Kolkata. So this is called as the forward approach. You can even start from Kolkata and then you can move towards Ahmednagar, but that is called as the backward approach. But we are not going to see that. We are only going to restrict ourselves with the uh, forward approach, right? So solution can be obtained moving in the forward direction. So what we are going to do is now we are going to make the recursive function, right? So the recursive function Fn is equal to the optimal value of Rn plus Fn minus 1 star, right? So your recursive function is normally given as like this, right? Fn star is equal to Rn plus Fn minus 1 star, where what is Rn? Rn is the it is distance travel in the nth state. You can even say this is what I've written in the generalized manner. You can say it is the time traveled in the nth stage, and Fn minus 1 is the optimal distance traveled into the n minus 1 stage. So here I forgot to give a star, right? So Fn minus 1 star है, जैसे यहाँ पे मैंने लिखा है Fn minus 1 स्टार, वैसे ये है. तो जब हम लोग स्टार लिखते हैं तो उसका मीनिंग क्या होता है? ऑप्टिमल, राइट? So this is Fn minus 1 star is equal to optimal distance travel up to the nth stage, right? So let's start this. We have to take this is the multiple stage decision. तो एक पे उसको सोचना है कि वो बी सी डी को जा सकती है क्या. तो एक कोई सिटी चूज करने के बाद सपोज बी पे वो बी के लिए जा रहे हैं, तो बी पे पहुंचने के बाद वापस से शी हैव टू डिसाइड whether she has to go for E, F, G, right? Let's say that she has decided to go F. So at F she again has to decide whether she has to go for H, I, G, H, I or J. So let's say that she has decided I, and then she will be traveling towards K. So at every stages, the Miss Vaishali has to take some decisions, right? So we are going to consider each stages. So let's say that she is at stage 1, right? And now at stage 1, the recursive function we can write. So what is now Fn? ये n है आपका stage 1 का n आप value हो जाएगा 1. So here we can write it as F1 star is equal to what is this Rn plus Fn minus 1 star. तो ये F1 star is equal to ये आ जाएगा आपका Rm1 plus F0 star. So this is very initial stage, So since there is no any stage prior to stage 1, what will be the value of f0 star? The value of f0 star will be equal to 0. Right? Now, at stage A, she is having three choices, B, C, D. Right? So now there are three choices available at stage 1, which are B, C, and D. So for node B, right? So for if I'm interested, for node B, what is the R1 value? The R1 value is nothing but the time required to travel from A to B. So the node value R1 value for B node is 6. Similarly, the R1 value for C node is what? 4. Similarly, R1 value for D node is what? 2. The same thing I have written here, right? So for node B, R1 value is 6 and F0 star value is 0. Similarly, for uh, there is one mistake again here. I'll be correcting that mistake and then I'll be doing. So these are not R2, R3. This is R1 only. So all these are R1 values only, right? So this is R1, this is R1, and this is R1 only, right? By mistake, got R2 and R3. So again for C, the R1 value is 4 only, and for D, the R1 value is 2. So if you see, this is 6, 4, and 2. Here also it is 6, 4, and 2. F0 star value is also remaining same. So can I find out what is the F1 star values for each of these nodes, right? So R1 value is 6 plus 0 is equal to 6. Here also it is 4 plus 0 is equal to 4. And here for D, it is 2 plus 0 is equal to 3. So now this is the theoretical explanation that I have given. Every time you don't need to write this, right? You can even represent it in the form of this particular table, right? So every time you are going to draw only this particular table. So for every stage, what two things are compulsory. For every stage, the recursive function should be written and this particular table is to be written. So same thing I have written. So stage 1 nodes are what? The stage 1 nodes are B, C, and D, right? The node at the preceding stage. What was the node at the preceding stage? It was A, that I have written here. There's no preceding stage, so it is A. Right? Input to the stage 1 node, so that will be 6 plus, that is the F0 star value, that is 6 plus 0 is 6, 4 plus 0 is 4, 2 plus 0 is 2. So for every node, we have got F1 star value, right? So optimal value at stage 1 is F1 star. So these we have found out here. I've just represented here in this particular table, so which is equal to 6, 4, and so for node B, the F1 star value is 6, for node C, the F1 star value is 4, and for node D, the F1 star value is 2, right? So let's move towards stage 2 now. The recursive function at stage 2 can be written as what? F2 star is equal to R2 plus F1 star. I'm hoping that you have got this, right? So now at node B, we have got this F1 star value is going to vary according to the node. So for node B, F1 star value is 6. For node C, the F1 star value is 4. And for node D, the F1 star value is what? It is equal to 2. Now, for R2 also, it is now R2 values are also going to get deeper. From B, if you go at B, from B we can move towards E, F, and G. So the values here are what? See, here the values are for B to E it is 4, for B to F it is 5, and for B to G it is 6. So it is 4, 5, 6. So for node B, the values for R2 will vary as 4, 5, and 6. Similarly, if we see node C, right? Node C also we are able to go to E, F, and G. So the values will be 5, 6, and 9, right? You see if I have written the same values, it is 5, 6, and 9. Okay. For node D now. For node D again there are three possible routes, E, F, and G. So here it is 5, here it is 7, and here it is 8, right? So 5, 7, 8. So it is the R2 value can be given as 5, 7, 8. Again, no need of writing all this. This is just for your explanation as we are into you know, the first numerical. You can even draw this particular table after writing the recursive function. So we have written the recursive function. So what are the stage 2 nodes now? Right, so previously here it was stage 1 node, तो अभी stage 2 nodes क्या हम लोगों के stage 2 के nodes से हम लोगों के E, F and G. So I have written those particular E, F and G nodes. Right, nodes in the preceding stage मतलब कौन सा वाला stage? ये वाला stage. इसके nodes क्या है? B, C, D. Right, so nodes in the preceding stages are B, C, D. F2 star value हमको find out करना, right? So here now 4 plus 6. What is 4 plus 6? That is not only we have to substitute the values here now, right? So R2, that is for the B node, and we are going towards E. So B E का value क्या आएगा? It is 4, right? So 4, 5 and 6. So ये 4 value यहाँ पे लिखा. F2 F1 star का value कितना है node B के लिए? It is 6. So 4 plus 6 is equal to 10. Similarly, from B I can move towards F, right? So from B to F, the value for R2 is what? From B to F, the value for R2 is 5, right? So that we can write here 5. What is again your B node का F1 star का value कितना है? 6. So 5 plus 6 is equal to 11. When I'm moving from B to G, right? So from B to G, the R2 value is what? It is coming out to be 6. So same way here, 6 plus the F1 star wala 6 is equal to 12. Same thing I can do for C. From C I can go towards E, F and G. So for E, F and G, the values are 5, 6 and 9 respectively, and F1 star for C is 4. So what I have done is 5 plus 4 is equal to 9, 6 plus 4 is equal to 10, and 9 plus 4 is equal to 13. Similarly, for node D, the values for E, F, and G are 5, 7, 8, right? So, and again the F1 star value is 2. So what here it is representing? 5 plus 2 is equal to 7, 7 plus 2 is equal to 9, 8 plus 2 is equal to 10, right? So now here we have to find out the optimal value. We are interested in going the minimization problem here, minimization of the time. So from amongst the 10, 9 and 7 value, which is the least value? It is 7 that has been written here. So amongst the values for F, from 11, 10 and 9, which is the least value? It is 9. From 12, 13 and 10, which is the minimum value? It is 10, right? So these are the F2 star values that we have got for E, F and G node. Previously it was not required for BCD node because there were no options. We directly got 642, but now here we have to select, and here we have selected the minimum value, that are 7, 9 and 10. Similarly for stage 3 now, stage 3 which are the nodes? Stage 3 के nodes हम लोग के क्या है? H, I, J. तो हम लोग मैंने यहाँ पे बस मेरा रिकर्सिव फंक्शन लिख दिया स्टेज 3 के लिए. स्टेज 3 का क्या रहेगा? F3 plus R is equal to R3 plus F2 star. तो बाकी मैंने कुछ ज्यादा एक्सप्लेनेशन लिखा नहीं. I can directly go towards the table. तो स्टेज 3 के नोड्स मेरे क्या है? H, I, G है. नोड्स इन द प्रीसीडिंग स्टेज मेरे क्या है? E, F, G है. So those nodes are written E, F and G, F, right? ऑप्टिमल वैल्यू क्या है वो मुझे फाइंड आउट करना है, राइट? तो स्टेज 3 के लिए वापस से मुझे जब मैं E to H जाता हूँ तो व्हाट इज माय E to H? सॉरी, लेट्स चेक. फ्रॉम E to H it is 8, from E to I it is 6, from E to J it is 12. So here you can see the value 8, 6 and 12, right? For E node, and for E node if you have to know, we have what? We have to star value as 7. So 8 plus 7, 6 plus 7 and 12 plus 7, the values are written here. Similarly for F node from H, I, J we have 9, 8 and 7. So same values you will be seeing here, 9, 8 and 7, and the F2 star value that we have found out was 9. So adding 9, so we'll be getting all this particular column value. Similarly for G, right? So G we have 7, 6 and 8, right? So 7, 6 and 8 have been written here, and the F2 star value is 10. So if you substitute the value in the recursive function, you will be getting all these values. Similarly, we have to take into consideration the minimum value. So 15, 18 and 17. So what is the minimum value? 15. Next is 13, 17 and 16, which is the minimum value. It is 13 that has been taken. Right. Next it is 19, 16 and 18, which is the minimum value. It is 16 that has been taken. Right. So now, lastly, what is our next node in stage 4? In stage 4, the node is K. So we have written सेम थिंग आई हैव रिटन स्टेज 4 का रिकर्सिव फंक्शन लिख दिया और उसके बाद तुरंत में टेबल पे आ गया. तो स्टेज 4 का नोड एक ही एक के है. तो प्रीसीडिंग स्टेज में हम लोगों के पास एच आई जे नोड है. ठीक है. तो एच से आई एच को के से जाने के लिए 3 घंटा लगता है या 3 यूनिट्स लगता है. आई टू के इट इज 4 यूनिट्स एंड जे टू के इट इज 2 यूनिट्स. सो हियर यू कैन सी व्हाट आई हैव रिटन द सेम थिंग 3 4 and now it is for H. For H node, what is your F3 star? It is 15, right? So 3 plus 15 is equal to your 18, right? For I node, what is your F3 star? It is 13. So 4 plus 13 is equal to 17. For J node, what is your F3 star? It is 16. So 2 plus 16 is equal to 18. Amongst this, which is the minimum value? It is 17, right? So this finishes our, we have reached the K. So what this 17 means, that 17 is the max, it is the minimum time that will be required for traveling from A to K. हम लोग को टाइम मिल गया पर अभी पाथ नहीं मिला है. 17 यूनिट्स is the minimum time that will be required, or it is the minimum value of the time that will be required from A to K. तो ये 17 अचीव करने के लिए हम लोगों को पाथ क्या होगा वो हमको डिसाइड करना पड़ेगा. तो ये हम लोग डिसाइड कर सकते हैं ये वाले टेबल से. राइट. तो अभी स्टेज, ऑप्टिमल वैल्यू, ऑप्टिमल इनपुट एट प्रीसीडिंग स्टेज और रूट हम लोग डिसाइड करने वाले. तो फोर्थ स्टेज में आपका F4 स्टार कितना था? इट इज 17. दैट इज वेरी एविडेंट, इट इज बीन गिवन हियर आल्सो. राइट. ऑप्टिमल इनपुट एट प्रीसीडिंग स्टेज. ऑप्टिमल इनपुट एट द प्रीसीडिंग स्टेज मतलब ये जो वैल्यूज है इसमें से सबसे छोटा वाला वैल्यू किसने दिया है? छोटा वैल्यू दैट इज F3 स्टार इज 13 which was achieved for node I. So that we are going to write F3 star value is 13 that was achieved for node I. तो मतलब हम लोगों को क्या मिल गया? अभी ये वाला नोड मिल गया. तो अभी हम लोग बैकवर्ड अप्रोच से जा रहे हैं. तो हम लोग को क्या करना चाहिए? I to K, ये रूट हमको मिल गया. This is final route. There is no route. You can't go from H to K. You can't go from J to K for achieving the optimality. तो हम लोगों को इस वाले टेबल से अभी क्या मिल गया? एक रूट मिल गया I to K. राइट. तो अभी नेक्स्ट अप्रोच थर्ड स्टेज हम लोग का F3 स्टार कितना है? हम लोगों का F3 स्टार 13 है. ये हमको मालूम है. यहाँ पे ये यहाँ पे भी देख के रखना है हम लोगों ने सिलेक्ट करके रखा है. F3 स्टार इज 13. नाउ वी हैव टू फाइंड आउट F2 स्टार. F2 स्टार कहाँ पे मिलेगा हमको? ये वाला है आपका F2. F2 स्टार कौन सा है? 7, 9 और 10 में से 7 है. और वो कौन से वाले नोड के लिए आता है? E नोड के लिए आता है. तो हम लोगों ने लिख दिया 7 और E. तो हमको और एक रूट मिल गया, वो है EIK. पहले एक नोड मिला था I, उसके बाद अभी और एक नोड मिल गया E. सिमिलरली F2 स्टार का वैल्यू कितना है? यहाँ पे हम लोगों ने लिख दिया 7. F1 स्टार का वैल्यू कितना है आपका? F1 स्टार. F1 स्टार में से इन तीनों में से सबसे मिनिमम वैल्यू कौन सा है? 2. that we have written here. F1 star is equal to 2. And it was for which node? F1 star value is for which node? It is for D node. तो हम लोगों को और एक नोड मिल गया रोकने का. इट इज DEIK. और D के पहले हम लोग यहाँ पे कौन सा नोड आएगा? A आएगा. राइट. तो ये वाला टेबल हमको कंप्लीट करना है. F1 स्टार इज इक्वल टू 2. F0 स्टार का सबसे छोटा वैल्यू क्या है? 0 ही है. और वो नोड क्या था? A ही है. तो हमको सीक्वेंस क्या मिला? ऑप्टिमल रूट क्या मिला? ADEIK. और टोटल यूनिट्स हम लोगों को कितने मिले? ये आपके F4 स्टार के लिए 17. तो हम लोग अगर ये वाला रूट देखे तो नो दैट दिस पल्लवी शुड विजिट स्टार्ट फ्रॉम अहमदनगर, देन शी शुड गो टू दिस सिटी D, right? Then she should go to this city which is E, then she should go to this city which is I, and then finally she should reach the final destination of hers which is Kolkata. तो हम लोगों ने क्या किया है? ये वाला ऑप्टिमाइज कर दिया। तो हम लोगों ने ये वाले स्टेज पे कुछ डिसीजन लिया, ये वाले स्टेज के ऊपर भी कुछ डिसीजन लिया, ये वाले स्टेज के ऊपर भी कुछ डिसीजन लिया, और फिर सब डिसीजन को एक साथ मिला के हम लोगों ने क्या किया, ये ओवरऑल प्रॉब्लम को हम लोगों ने क्या कर दिया, सॉल्व कर दिया। So this is how this dynamic programming is working for this type of